fine? Okay. So please welcome Krzyk on the stage.
Okay, hi. Hi, I would like to tell you our war story in Allegro. I would like to discuss with you about something else what you do all the time, because as far as I know from yesterday's discussions, most of you have a ops background. I have multiple backgrounds, but I would like to tell you how to switch from developer to DevOps. How to cope with team that is core Java developers that want to deal only with libraries, that want to build code that would be reusable everywhere, and how to make them be DevOps or to know all the stack that they're building their tools on. I'm Krzysztof Dębski. I work for Allegro for almost 6 years right now. I'm for 15 years in IT, and I'm product owner of Hermes. Hermes is a tool that covers Kafka and expose REST API and expose some additional features from Kafka, such as security, etc. And I work for Allegro. Allegro is a quite big company. It's almost more than 500 people in IT. And what is important for us, they work in almost 50 separate teams. We are working in Scrum teams, so the tools that we are building in one team not always are distributed to all of the company, and the culture that we are building in separate cities, because we are in the 5 cities right now, are not always distributed to all the cities. We are 16 years on the market, and 3 years ago we decided to switch from monolith to microservices, which we thought it would be a great idea, but actually it brought us a lot of pain, a lot of headache, and a lot of issues that we need to cope with that we didn't knew that existed. Years ago, because I'm from Krakow, I worked in Poznań, and I had my team in Warsaw. So I need to move to Warsaw, and I worked with teams that existed in Warsaw. I used to work with the Poznań culture, and then I saw that in Warsaw there's totally different culture. There are Java teams and there are ops teams. They don't work together. They only work together when they need to deploy something. So usually it worked somehow like this. We had a developer that code, and then he came to operator and asked, well, you know, there is a puppet I need to have my instances. Please do it for me. Then spawn instances for me, and then we'll have our running application. And it was great for the first installation of application, but then we had to scale our application. So only developer was the person that knew how to scale. What are the metrics that say we need to scale application? It might be a number of transactions per second, it might be IOPS, it might be any metric, but only developer knew exactly which one we should look at. So then he came to operator and asked, please scale my application, please spawn me some additional instances. And it was like, well, okay, I will do it for you, but why? Yeah, you know, because I need to have more IOPS, I have to cope with more transactions. So we need to have some kind of ping pong between ops and devs just to cope with such a simple thing as a scale application. So we thought, maybe there's gonna be some better solution. So let's mix them together. Let's get some operator from the ops team, and let's put one operator to every single developer teams. We thought it would be great, and I had it in my team as a product owner, and I thought it would be great. So one of the first sprints, because we worked in Scrum, was like 13 completed issues in my sprint and 7 not completed issues. It's not as bad as it looks like, but if we look at the ops issues, it was always 0 ops issues fixed and 2 not fixed. And we always had the situation on this refinement when we decided what to do on the next sprint. Okay, let's do this, this, and this. And we had 2 sub-teams, devs and ops. when I asked, well, you know, I need to have Graphite installed just to monitor my applications. Okay, it's no problem, it's Bartek's responsibility. It's his responsibility, my devs said. It's his responsibility. We don't know how to install Graphite. When we discuss about applications, my administrator told me, well, you know, I don't know what you are talking about. You are talking about some threads, you are talking about some scalability issues. I don't know what you are talking about. So we had one team, but actually we had two culture of working. We had Scrum with developers, but actually our administrators tend to work in Kanban. They tend to work, okay, give me some issues that I need to work with, and then I will do it piece by piece. I will do it my way. I don't need you to tell me how to work with it. So we thought maybe there is a better solution to cope with this issue. For me, the better solution is not to mix people, but to expand the knowledge and expand the responsibility. So we thought maybe it's better to have our administrators to work together on the infrastructural tools to expand their knowledge and the responsibility to the application level, and maybe it would be better for our developers to tell them how it really works, how bare metal works. Maybe they should look deeper than only libraries. So we decided to have that kind of experiment with the team that I have, and we built Hermes. Hermes is just a wrap on Kafka. It exposes some REST interfaces, as I mentioned. It gives us a lot of feature to have some PubSub in our infrastructure, and it's actually open source. So we built it. And in the first test, when I asked developers, please provide me some performance tests, they claimed, okay, on the single machine, it could cope with 60K requests per second. Great, hooray, we can just install 2 or 3 machines and it would be great. I don't need to care anything about Hermes anymore. They claimed, well, you know, for the 99.9%, it's great. It's like 100 milliseconds, here it's 40 milliseconds, it's great. For the rest of the events, it's more, it's 1 second, sometimes more, but what we don't care. We care only on throughput. So it was our first issue, which we realized on the real environment, that we need to focus not on throughput, not only on throughput. We need to focus on latency. Why? Because when we deployed it on the production environment, it wasn't 60K per second. It was 5K per second. Why? Because when we tested it, we made a huge mistake. There is one situation that is called coordination omission, when your tool that tests your server and your server cooperate with each other. How would they cooperate? Usually, when you test something, you have, for example, 100 test threads, and they just send requests. When you have your server that answers slowly, what your test tool do? Okay, I won't send you more than 100 tests. I will wait till you will send me answers, and then I will send you more requests. What happens in real world? If you don't answer me, maybe you will answer me again. Maybe you will answer me again. Maybe you will answer me again. In real world, it works totally different. So in real world, it is this issue. In test environment, we had the situation where everything works great, and then we have issue. In real world, we have issue much earlier. We have issue much earlier, and again, when we have issue, the issue becomes larger and larger because our clients start to send us more and more requests per second. So that's the moment when we as developers, when you as ops, need to understand both sides. So we need to learn how it works in the real life. And we looked at when we realized that, we looked at the slow responses. It was also interesting because we had application which was Hermes, beneath was Kafka, And we realized that in Kafka run on kernel 3.2, there are huge issues with this long tail. We have huge issues with the small amount of requests. We looked from the very top, from Hermes till network to the Kafka insights, and then we finished in kernel, and then we looked at the Kafka, how it interacts with kernel. Actually, Kafka is fast, not because it's Java is as great. It's fast because it uses Java unsafe. It saves data directly to the memory. It obeys all the rules. It not goes with all the rules, but it obeys it, and it saves that directly. And in kernel 3.2, there's an issue till kernel 3.8. If you have pdflash should be non-blocking. But in the old kernels, there's an issue which blocks writes to dirty pages till all the dirty pages are stored on the drive. So pdflash blocks all the writes. And we had this issue, which we saw on the very top level on the application, which actually lies on the very low level of our application stack. So to understand why our application responds slowly, we needed to look almost on the bare metal. We also had some issues with the connection to the service. If you are a developer, you look, okay, my application is standing, okay, everything should be all right. But if you're an administrator, you look, okay, maybe there are some lack of file descriptors, maybe there are too many open files. Okay, so we can fix it. And then you realize that you still don't receive traffic from your clients. We also had this issue, and then we realized that it's not the lowest level. You still have bare metal below. You still have bare metal, and you need to look, if you don't receive requests, you should look at the very top level. And in this situation, we had a funny situation, because we were running OpenStack, and depends on which physical server we were running our application. Sometimes it gets requests, sometimes not. It's all because of your neighbors. Because we had some greedy neighbors that got all the huge traffic, so it had all the contract limits. So we have really few actually connections that we can deal with. So we looked from the very top till the bare metal, and there is something more. There are clients. There are clients that we need to know how they work. There are clients, there are network. There is a really nice algorithm that saves, that is great with network, that saves bandwidth for you. It is called Nagel's algorithm. If you look at the network, the TCP, there are 40 bytes of header. And if you are running telnet or any that kind of tool, and you just write single letter, it is 1 byte. So if you are adding 40 bytes of header, it is huge overhead. So there's Nagel algorithm that usually waits some time till the next bytes will come to pack them to the bigger TCP packet and send it to the client. And then we realized that sometimes we had really small events that we need to send via network, and then system on the client side implements Nagel's algorithm, so it waits for about 30-40 milliseconds. Maybe something more will come. And when we have 100 milliseconds timeout, it was after the timeout, so we didn't receive any requests. So that was, again, issue that came from the very top till the event client. And then we realized that on the small traffic, we still have some issues from the client side. I asked administrators, please look at the servers. And they did what they can do best. They did LSOF. And they saw, okay, there are some leaking sockets. There are some sockets that we cannot identify. It's just can't identify protocol. It is very common issue, but we don't know how to cope them because we don't know what's at the source, what are the root of this issue. So again, we saw this from the administrator perspective that there are issues, there are leaking sockets. So what we can do? Let's restart. And then we saw that again, we saw that again. It's all because of our clients. So again, of issue in our application and our clients. If you are using HTTP 1.1, there's really nice feature which is called transfer encoding chunked. When you don't say upfront what is the content length of the request that you will send, you just send chunk. Every 2 lines is a chunk. You said, okay, I will send chunk which is 26 in hex, and I will send it, and the last chunk is the empty line as in HTTP. And we had some issue in code that waited till the last chunk of the request, but it never came because client already disconnected. And we had this issue that we didn't realize that client disconnected. We had half-closed socket, which we didn't know that can exist from the developer's perspective when we looked at it. We expected this to happen. And then from the administrator perspective, we saw just socket that leaked from the applications. And we just need to look from both perspectives to know how to deal with this. The last thing that we used was the tool to configure our applications. We used 2 tools because we had developers and administrators, separate teams. We had Zookeeper for developers and Puppet and Kiera for administrators. When we tried to mix it, when developers tried to use Puppet, all the administrators told them, well, okay, it's no problem. It's just a rubbish, so you can use, you are developers, you know how to deal with this. But we need to teach you what are our domain, because we have almost 20,000 files in our Puppet. So you need to have our domain knowledge, how to deal with it. And then we will make a review to look whether you are not messing with our stuff. And you know what? The same situation happened with Zookeeper. When administrators tend to put something to Zookeeper, then developers said, well, you know, we have it all in one single configuration in Git. So if you want to put your configuration in Zookeeper, we need to review it to make sure that you won't mess with our configuration. So we have still 2 words that don't want to work together. So we thought it would be better to use both experience and to use something else. We decided to use Spring Cloud Config. When you store your configuration in your repository, so you are the owner of the configuration, and the owner of the configuration tool doesn't know anything about your configuration. And we wanted to use the best what we learned from the ops perspective. We wanted to use HTTP2 because it's nice, it's binary, it has support by default for SSL. And we decided to use the best from we know from the ops perspective, to use client certificate to make the configuration safe. So we mix our knowledge from both perspectives, and we decided to use configuration in other way. So what we learned from this situation? The first thing was what is obvious, but it was kind of interesting for me. When you mix dev and ops and put them in one team, it doesn't make DevOps. It doesn't make them work together. You need to change the culture. You need to make people curious about what happens in some other layers of application to make DevOps. If you want to deal with really a high-performance application, you can't stop on your layer of knowledge. You need to expand your knowledge. You need to have DevOps. You need to have people that looks from both perspectives. And last thing, if you have really issues with your application, if you look from only one standpoint, from one viewpoint, from developer's viewpoint or from ops viewpoint, you will do nothing. You cannot cope with really hard issues if you don't cooperate or if you don't have DevOps. If you don't have DevOps, people that really can look through whole your application and whole stuff under your application, then you cannot cope with really hard issues. Thank you. I encourage you to visit our blog, Allegrotech. Thank you.
Thank you so much. We still have some time for additional questions. Anyone interested in getting more info about? Yeah, we have a question here.
Hey, how does it look like from management perspective? Are there any obstacles?
Are there any obstacles? Yeah, there are. Because if you are building kind of DevOps, you need to invest and you need to have. It's hard to find that kind of people. It's hard to encourage people to look at the other sides of the wall. It's hard to encourage developers to look at the ops side. It's hard to encourage ops to look at the developer's side. It's hard to manage people to expand their knowledge. That's the first thing, and and I would say there are not every single team need to have all the developers to be DevOps and all the ops to be DevOps. You need to look at the specific place where you need to have a DevOps on the, for example, on the really hard pieces of your application. And I think that's the main issues. There are always people issue from my perspective.
Okay, thanks.
Thank you.
Okay, thank you. One more question. Anyone?
Here we have.
Oh, sorry.
Okay, when people finally understand the DevOps mindset, then the work is going. But how to start? I mean, what was the most difficult one of the first steps to convince Java developers to start looking outside of their comfort zone?
It's a great question because we had. It was hard for us because we realized that our administrator want to expand his knowledge to build DevOps, and he want to be outside of our team. So we thought, okay, either we will do it by ourselves, or we will won't do it. So we had to do it. So it was like it was really hard way. We thought, okay, we need to be alone with this. We need to cope with most of the issues alone because we don't have any help. So it was like either you will do it or we will collapse. In our perspective, it's much better if you can have some help and if you can have admin that will join developer team and share knowledge. It's much better. But in our perspective, the best was hard way.
From our place, I would like very to help our Scrum teams to start thinking more broadly in context of their applications, and we had the new components in that was recently started, and those guys was set as to create their own installation scripts. We use Ansible instead of Chef, but this doesn't matter. And they used they should create their own Jenkins flow, and they didn't wanted to. They closed themselves and tried to create everything. But when they hit finally the wall, they didn't want help. I mean, come to us, sit with us, and to help us understand how it works. They just pushed away all the work, and they tell, okay, this shit doesn't work. Create that for us, and then we will use it.
So the also important thing is to have a mentor from other side of the wall, as you said. It's really important to have someone who will tell you what to do. It's really hard to, if you are a developer, to deal with all the stuff. It's almost impossible. But you need to have some mentor.
Yeah, but I mean, I was able to help them. I was available to help them. But they, instead of seeking for the help from the ops side, they closed themselves.
Okay. No. It's hard to say. Maybe it would be better to join the team and to have responsibility for you and the team for the same product. Because maybe they treat you as someone from the outside, just to you know the pigs and the chicken and the pig. You know, you are just a chicken. You are just do this. Maybe you should just work together on single product. Maybe.
Okay.